Hello everyone, in this video we're going to talk about how to find the horizontal asymptotes of a rational function. Okay, so when we're dealing with the horizontal asymptote, there are several rules that we're going to follow, and we'll talk about those here in a little bit. But a horizontal asymptote is similar to a vertical asymptote, except that the line that we're now looking at, this imaginary line, is going to be horizontal. And there are several rules, right? It could be the x-axis, it could be over at y equals 0, or it could be at some other number. Let's just say -2. Right? There's a lot of different possibilities for horizontal asymptotes. And then a function can even have no horizontal asymptote. At that point, it would have a slant. And we might do an example of that here. But there is three possibilities. A horizontal asymptote at y equals 0, a horizontal asymptote at some other number, or where it doesn't have one at all. Now, what we're really more interested in when we're dealing with horizontal asymptotes is what happens to the function as it goes to infinity and negative infinity. Okay, what happens in the extreme ends of the graph, not along the middle? Because what happens sometimes along the middle, a graph can, let's say that we have several vertical asymptotes. I'm going to put this in. Well, let's just start with the basic rule, right? A regular horizontal asymptote is going to try to approach that line, right, as it gets to it. I like to use my pencil and put it horizontally and see where it crosses the y-axis. And what's that imaginary line that the graph is not going to touch? Now, depending on the vertical asymptotes, like we might have multiple vertical asymptotes. Okay, and in these vertical asymptotes, we have a section here at the bottom. Whenever we have two or more vertical asymptotes, crazy things can happen in the middle. You can have a cubic function middle, a parabola in the middle. You can have all kinds of stuff happening in the middle. But what's important to know is that horizontal asymptotes can be intersected and touched. Vertical asymptotes, you cannot at all. Okay, but what's important about horizontal asymptote is what happens as it goes to negative infinity and positive infinity. What line is it trying to touch on the ends? Like notice how here in the middle, it does cross the horizontal asymptote. It does cross the blue line right here. And that's okay, because we're interested in what happens at infinity. It's going to get to -2. What happens in negative infinity? It'll also try to get to -2. So we're really interested in this imaginary horizontal line and really what happens in the long run. Not necessarily in the middle, but more about what happens to positive infinity and negative infinity. Okay, now to find these vertical asymptotes, we're going to be dealing with the function itself, like the rules. How do you find them will be based on the function itself. So let's say that we have a function, as an example, x squared plus 2x plus 5 divided by x plus 1. Okay, what we're going to be focusing on to find these horizontal asymptotes are going to be the leading exponent of that function. Now this in the bottom, we technically have an x to the 1 power, right? So we're going to be comparing the exponents. On the numerator will have an x squared, the denominator will have just a regular x. Is the numerator bigger than the denominator? Are they equal? Is it less than? What is happening there? Okay, so here's another possibility that we can be able to see. Let's say we have x squared plus 2 over x squared plus 7x plus 1. Notice how here, in this scenario, the numerator exponent equals the denominator exponent, right? So when we're talking about these next three rules in a little bit, we're referring to the numerator exponent compared to the denominator exponent. And whenever those functions either are the same, greater than, or less than, we'll be able to determine where exactly is this horizontal asymptote happening. So let's get to it. Let's do a couple examples of each. So here we have three rules that we're going to talk about in a minute. Okay, the first rule is what happens when the numerator is less than the denominator. At that point, the horizontal asymptote will be at y equals 0 or the x-axis. What happens when the numerator is equal to the denominator, like an x squared over x squared, like we just spoke about? At that point, we would use the leading coefficients, so a over b. And then what happens when the numerator is greater than the denominator, like x squared over x, or x cubed over x squared, right? At that point, we do not have a horizontal asymptote. We would have what we call a slant asymptote. We won't be talking about how to solve for a slant, But as long as we know that it doesn't have an asymptote, horizontal asymptote, that is good enough for now. We'll revisit these rules after I give you an example of each. Okay. So rule number 1, whenever the numerator is less than the denominator. So what do I mean? Let's look at the exponents. Notice how in this first function we have x, or x to the 1 power, over x squared. Here you can see that the numerator is less than the denominator. So whenever this happens, your horizontal asymptote will always be at y equals 0. Notice how here in the other equation we have a 1. There's not even an x value. Technically, this is the same thing as saying x to the 0 power, because there is none, over a regular x. The numerator is less than the denominator. Again, the horizontal asymptote is at y equals 0. And then here below we have another example where we have x squared over x cubed. So notice how the squared is less than the cube. So in this situation, we have numerator less than the denominator. Again, y equals 0. So the horizontal asymptote will always be 0 whenever the exponent in the top is less than the exponent in the bottom. So let's do an example just to sort of see what this looks like. Okay, let's talk about this one right here. We'll do y equals 1 over x minus 2 here on Desmos. I'll show you what the graph looks like so you can see this horizontal asymptote. All right, so here I have the graph 1 over x minus 2. Notice how here you see the function on the left trying to approach the x-axis, and on the right as well, left and right, and it will never reach it. I'm going to draw an imaginary line here at y equals 0. And make this one dotted as well, like we did earlier. Notice how here we have a dotted line that the graph is going to try to touch at y equals 0. This one's going to be written in the form of y equals because it's horizontal and it's touching the y-axis at that particular spot. So notice how if I zoom in, the graph as you go to infinity will try to touch it, but there will always be a gap between the asymptote and the function itself. So this is what a horizontal asymptote looks like. All right, let's try another example. In the second rule, we're looking at what happens when the numerator exponent is the same as the denominator exponent. What happens when they're equal? Here, as an example, notice how we have just a regular x and a regular x. Over here, we have an x squared over x squared. And then over here, we have a regular x and a regular x. I put x to the 1 power because it's the same thing. Whenever you have the exponent on top matching the exponent in the bottom, you're going to look at the ratio of the coefficients. What does that mean? Is we're going to be looking at the numbers in front. So in front of the x, we technically have a 1. In front of the bottom, we have a 2. That ratio, the asymptote will always be at that ratio, 1/2. Over here, we have 1 over just 1. So the horizontal asymptote will be at 1. And this last one, we have 4 over 2. So the horizontal asymptote will be 4 divided by 2, which will be at 2. So this is why the horizontal asymptote can change to a different number. It could be a half, it could be 3/4, it could be 8, it could be 16, it could be any number as long as we're looking at the ratio of the coefficients. Whenever the values match, the leading exponents match, then you just take the numbers in front and you make it a ratio. Sometimes that ratio is a whole number, sometimes that ratio is a fraction. So let's try one of these out so you can see. Let's do this one in the bottom. We're looking at the horizontal asymptote to be at y equals 2. So we have 4x plus 6. Let's graph this real quick. 4x plus 6 divided by, say, 2x. Now the horizontal asymptote will be at y equals 2. This imaginary dotted line that we drew in there. Now it's not the x-axis anymore at y equals 0. Now it's at y equals 2. And you can see how it's going to try to approach it, but it'll never reach it. With these horizontal asymptotes, you will always have only one horizontal asymptote. Vertical asymptotes, in my other video, you can have multiple vertical asymptotes, but when it comes into horizontal, there will always only be one. Let's talk about this last rule. This last rule is about what happens when the numerator is greater than the denominator. Okay, what happens when that occurs? So notice how here we have x cubed over x squared and x squared over just x. Whenever the top is greater than the bottom, we're going to say that there's no horizontal asymptote. None. It does not exist. Instead, we're going to say that we have a slant asymptote. And now what this means is that the line, instead of being horizontal, we're dealing with a line that is slanted, diagonal. Now, we're not going to be dealing with these examples at all in this class because it's more like a pre-calculus concept or higher than algebra 2. But as long as you're able to recognize when you have an asymptote or when you don't, that's what we're worried about here. So let's recap the three rules. We have three possibilities. What happens with the numerator is less than the denominator, right? We have y equals 0, or the x-axis becomes your horizontal asymptote. What happens when they're equal? You use the ratio of the coefficients, right? X squared over x squared, you use the numbers in the front, a over. And then what happens when the numerator is greater than the denominator, like an x cubed over x squared? At that point, we have no horizontal asymptote. Okay, I hope this helps help you review for your test and learning the material we're covering right now. And as always, we'll calculator.